my first encounter with bamboo was by going to a conference about 20 years ago and listening to Simon Velez talk about the buildings that he had built. And what was really interesting was that the people organizing the conference, they came and apologized at how few English words that Simon could speak at the time, and I just couldn't believe what an amazing presentation that was. It was as simple as, this is concrete and bamboo, next, and every slide was, to me, one of the most amazing things I've ever seen. And it didn't take language to explain it. It was very clear that the things that we've been searching for are contained in these buildings. These are ways of building that you can continue to build without running out of your building material, and it becomes super strong when you apply a little bit of technology to it. And so that's what he had done, was invented the bolted and filled joint. So the traditional joinery of bamboo is that you just run one pole past another and you tie it. So whatever tying that you do is going to come loose over the changes in the season, changes in moisture in the air. Especially with natural fibers, if you tie it, that will become more slack. And so your entire structure, by extension, becomes very mobile. It can move quite a bit in the wind. Then the next step forward is that you can put pins. You can carve a bamboo pin and use that as your joinery between poles. But if you think about it, this little pin going between poles, it's only touching the very edge of the bamboo pole. And so the surface area that transfers the load from one bamboo to the other is very tiny. You're hardly getting much help to make that joint. And so Simon's big step forward was to drill a hole, put a bolt through there, and to fill the area around where the bolt goes through with something that turns from a liquid to a solid, so that we're using mortar for the most part. But the idea is that you've increased the surface area of where the bolt is touching the bamboo from just the very edge to now the entire surface of the inside of that plug that you put in there. So it's literally hundreds of times the surface area, so much stronger. So it means that you just have a joint that doesn't fail. You can't get that to come apart. And the buildings that I know of that they've wanted to take apart, the only way to do it was a combination of bulldozer and explosives. Well, if you compare bamboo to steel, just the fiber itself is stronger, equal weights of bamboo and steel. The bamboo is actually a stronger fiber in tension than steel, which it sounds like it's saying a lot, but the problem has been, how do you join together the tips? And that's where the weak link had always been, until we saw some of the work by the Colombians, Simon Velez, Marcelo Villegas, and the people that worked with them came up with the system that kind of overcame the problem of joinery. And that made this an engineering material that's really equivalent to anything that we can get our hands on in the industrial world. So you start off with the fact that if you planted bamboo versus a softwood forest, you can get, depending on who you believe, between 3 and 19 times as much fiber per hectare with bamboo. Then your next step is you can harvest every year rather than having to harvest in much longer cycles. Um, and then you can use the various parts of the bamboo for different purposes. Like the leaves are very high in nitrogen, higher in nitrogen than alfalfa certain times of the year. So as an animal feed, the leaves are great. They're going to supply a great deal of a vertical pasture, a way of growing your grassland in a very vertical, tall way. So in terms of surface area, you can grow a lot more leaves than you can grass. And that material can then be fed to animals. The branches and the smaller cutoffs can be made into charcoal. And then the culms themselves can be, obviously that's something that we've talked about, and it can be used to build just about anything you can come up with. One of the really exciting developments in the last few years is what people have come up with using splits of bamboo. So if you take the whole culm and you split it into multiple pieces, those very flexible pieces can then be used to make curving beams and various kinds of curving structures that were not conceived of in the past. So I think we're just at the beginning of exploring what that could possibly mean, but it also implies that you can use a lot of the lower quality poles and the pieces that were otherwise waste in the past. Yes, in a word. If you go to the very southern edge of France, you can find the bambousserie, that is a good example of how bamboo can grow in a European climate, in a climate that it does get cold, and there is a way to have a huge quantity of it. They've developed that into quite a large acreage. And most of the bamboo that has been grown in Europe is in some of the warmer places like Italy or Spain. But there are examples all over the place of where temperate bamboos that can survive pretty significant freezes. The problem in a lot of Western countries, like in the U.S., for example, we don't have the monsoon rains all summer long. Like most of the bamboos are really set up to have rain every afternoon in the hot season. And in California, we get no rain at all the entire summer. So the bamboos really need people in order to even survive, let alone to do really well and to become a major force in the building industry. So if we're talking about planting entire forests, it's hard to go out and water each plant individually. But the vision that's a little bit different, and it's maybe more interesting, is that in a small piece of land, a person who is a builder can control their own source of their livelihood. They can control where they're getting their material, how it's grown, what quality it is, how much is available right outside their own door. And that's a big difference between bamboo and just about any other material except maybe earth. So you can, in contrast to almost any other material, not have to be dependent upon material suppliers. It will be driven by running out of fossil fuels. So when it is too difficult to build the very energy intensive materials that we've been using for the last 100 years only, then we will go back to improving some of those original simpler techniques, So it's up to the few of us who've been experimenting with it to kind of lead the way and make it so that it's an obvious choice. It's just a better way of building, and that's what we need to be aiming for.